So before finishing off the tutorial, I would like to make one more announcement related to my courses. So right now on my website, I have three courses right now available. One is a STM32 introductory course, which will teach the essentials of STM32 programming. And also the second is the attitude estimation. Here I will teach more advanced topics. Also I will explain how to work with the IMU sensors, and also will present Kalman filter quaternions for the attitude estimation. And the last but not least, I have a course about designing the balancing robot. It is, in my opinion, it's really great course because it will teach not only embedded programming, but also you will learn robotics topics. So you will learn how to work with the IMU sensors, how to compute Euler angles. Also, we will learn system modeling, and finally, also we will use PID and LQR, linear quadratic regulator, to balance the robot. And all of these things will be implemented within the microcontroller. And currently I added LQR topic. So if you show the content, so I added linear quadratic regulator. So it explains state space design, and we model the balancing robot, and finally we implement everything within the microcontroller. And the price is still low, so you still have a chance to access this course with a very low price. Okay, so I promise not to announce anything anymore, so we will solely focus on the tutorial. So we have the flash memory. We know how to work with it. So next thing, we need to send our binary file from Python to the microcontroller. So if you go to your project, as you see, we have this binary file. So this thing, we have to send it through the serial port. So if you don't see this binary file, go to the settings, properties of the project, and if you go to C++ build, go to settings and MCU settings, build up outputs, and here you just need to tick this box. You can apply and close. Okay, so we need to send it, but one important thing is that if we just send it, we can mess up with data. So that's why I decided to create a very simple packet format. So in this packet format, we have the following structure. So first I send the message token, which value is 23, but of course you can set any value you want. And then we have the command. So right now I have three options. And again, I made a small typo. This is not 23, it is actually 42. And again, you can use any value you want. So if the second byte is 42, it means that we are sending the binary file to the microcontroller. The second, this command means that we are asking the microcontroller to toggle the bank, so it will start executing the second application. And this command is optional. This is just to verify that we successfully flashed the microcontroller. Then we have data size, which is 2 bytes, followed by the real data, and finally we have SRC. And within my project, I have this function to pass the data we received, and also we have this struct just to keep all the parts of the command separately of the packet. So first thing, I check whether the first bit is equal to message token or not. If not, of course, I return some error. If everything is fine, I check the command number. If the second byte is equal to none of the commands, I again send some error, return some error. If everything is fine with that, we have the command, then we get the data size, so we get 2 bytes, and also we check the size of the packet received and the data size. So these values have to be equal, otherwise I return this error. If everything is fine, we take the data pointer, and also I make sure that we have the same SRC. So the last 4 bytes are SRC from the Python, from the host, and this SRC. Then we compute SRC when we received, and they have to be equal. Otherwise, I return a serial SRC error. And all these are defined within the header file. Okay. So this is, I guess, pretty clear. So I will explain. So we need to use this parse request function every time when we receive data through UART. So within the while loop, I check the UART size. So this is equal to the size of the data we received from the UART. So if it is not equal, I pass the request. And if this function returns some error, what I do, I return NUC. So we have acknowledgement, and if something fails, I return just a one byte, which is equal to AA. Okay, or you can use any number you want. And for acknowledgement, I use a 5F. So I return NUC, but if everything is fine, so all the packet has been properly parsed, and then we just check this command PC command type. So if it is request to update, meaning that we received some part of the binary file, and if we receive it for the first time, we just erase the bank. So this address is basically, it's a local variable which is equal to the bank address. So if we are receiving data for the first time, this address will be equal to the bank address. Okay, then what I do, I have this address, and we have a data of the command and data size. So this we got it from here, from this parse request. It happens just over there. We have data size and pointed to the data. So then we need to, of course, increment. We have to add this data size to the address. So when received next time, we store it in a proper place, and then we have to send the acknowledgement. And if we have change bank request command, we just toggle the banks, and we have to send acknowledgement first, because after toggling the banks, after swapping them, the microcontroller will be reset automatically. And if we receive firmware version request, I just send this application message through UART, which is equal to hello from application 2. Actually, we can change it to application 1 for a while. Okay. Next, let me show the Python part of the tutorial. So here the main function is this update flash memory. So here what this function does, so first of all, it has 2 arguments. First is the serial communication, serial port, and second is the file name. So right now, for example, I have this custom bootloader STM32 binary in this folder, within the folder where this Python file is located. So what you can do, you can just, for example, go to your project, you compile it, you can build it. Once you have built, you have this binary file, so you can just copy it, copy, or you can press Control C. Then you go back to Python script and you can paste it here, Control V. And it is asking me whether I'm sure to replace, to paste. You can say paste. Okay, since I have old Z, I cannot do it, so I can delete the old version and I can paste it here. So what this function does, first it reads this file with this file name, and if it cannot open, it throws this exception. If everything is fine, it gets the size of the binary file. And when we send this binary file to the microcontroller, of course, we don't send it in one transfer. Instead, we divide it into small windows, and every iteration we send each window separately, basically. And the window size is 128 bytes. So what I do here, first I need to create, of course, the packet. So the first thing in the packet is the message token. Then, of course, when sending the binary file, I have this boot update request command, and then I convert it to the bytes by hex numbers, basically. Then we have size. I copy to another variable, and then I start reading in every iteration this amount of bytes from the binary file. Okay, then I have to decrement the size in every iteration. So we have data to be sent, we convert it to, and then we add the size of it. So usually it's 128 bytes, but sometimes you might have the last packet might not be 128, it could be less. That's why I take the length. So this data send is first tokens, this message token command byte. Then we have the length. Then we have the data, and then I send it to the using this function. And you might ask where the SRC is. So if I check this function, send data serial, as you can see within this function I add SRC just over there. So this capital I means we have 4 byte unsigned integer number. Then I wait acknowledgement. So we have this function for that. It just reads 1 byte, and if it receives acknowledgement, we return acknowledgement. If not, is not. If it is not, we return this. So if it returns, if we don't receive acknowledgement, I just print it and I throw an exception. And then if I reach 100%, so if I send the whole byte, I print this message firmware update is over. So for reading the firmware version, like reading just a message, I have this function, which is also really straightforward. We have message token, the second firmware version request, and the next bit is 0, because when we are asking to read the firmware version, we are not sending any data. That's why it's just a 0. And then after sending, I just wait 27 bytes, I expect, and when I receive, I just print the message. And to change the firmware, we have the similar thing. We have the command is change bank request. I send it, that's it. And all these commands have been defined just over there. Nothing special. And these numbers has to coincide with the numbers you define within the microcontroller, of course. So to check all of this, I have this while loop. So I can enter 1, 2, or 3. If it's 1, I send this binary file, and of course you can use any file name you want. So you can, if you have different project name, you end up with a different binary name, file name. So you need to use the corresponding one, of course. And if it's 2, it will request the microcontroller to change the firmware. And this is to read the firmware version just to make sure that everything is working. Also, I forget to mention that within the system STM32 file, we have to uncomment this line. Otherwise, it will use the default vector table address. But as I said, every time we change the bank, we have to change the vector table address. So if we uncomment it, it will happen like automatically when you compile things. So I will explain maybe later more deeply why we have to uncomment this line and what it means. But just for a while, you can just follow my instruction and just uncomment this line. So that's it, right? That's it. And it is time to check our custom bootloader. So what I do, I press the debug button. And also we will run the Python script. So right now I'm in debug perspective, but of course we will not use it. We will use just our Python script to flash our microcontroller. So I'm just terminating, but for the first time, of course, we have to flash the microcontroller. So next thing, let me disconnect my microcontroller. I run the script. Okay, so first thing we can check the firmware version, which is basically just sending just a dump message. So it returned hello from application 2. And right now we change it to hello from application 1. So right now I'm going to send, let's say, what I can say, hello from application 8. Not so important. We can build. Then we have a new binary file, which already takes account to the changes we made. So what I do, I just copy this, go here. I can delete this binary file. I can paste it here. Paste it. Okay, then I can press again 3 just to make sure that it's still running. Then I will send 1, so it will do firmware update using the binary file we've just compiled. So it will send this binary file to the microcontroller, and it will send it to the second bank, and it will swap. So let's see what's going to happen. So it should do it here. And also I have this printing just to make sure that how much we sent. So it is almost 100%. Yeah, firmware update is over, but it just stored the binary file within the flash memory, but it didn't do this swapping, the toggling of the banks. So in order for this to happen, I need to send a 2. So I send 2. And next thing, if I press 3, if I check, guess what kind of message we need to receive? Of course, hello from application 8, which is the change we've just made. So Next thing, what you can do many other kind of changes. You can compile and you can easily send this binary file through the through this Python script, through the serial port. Everything is quite stable, I would say. And let me check again. And what we can do, we can go back to our old application. So if I press 2, it will toggle the banks again, and it will run the application that was running before. So right now, look, if I send 2, okay, so let me move up. So if I send 1, we will receive up. Wait, I'm updating. I need to. So I'm sorry, I mess up with the command types. So I'm going to right now flash this binary file. So I update it, then I change to this new application we've just sent, and if I check, it returns hello from application 8, and this microcontroller still holds the old application. So what I can do, I can just toggle to that application. So I send 2, and if I send 3 just to check, it will return hello from application 2. So we have 2 applications within the microcontroller, and we can choose any application we want to, and we can choose either of them by sending these 3, by sending change firmware request. So if I toggle again by sending 3, by sending 2, of course, then if I check, I'm in application 8. So this is the end of the tutorial. We successfully designed a custom bootloader together, and everything is working. And we covered a lot of things, a lot of important things, and I'm pretty sure that you learned something new. And if you like the video, please don't forget to press the like button and subscribe to my channel. And if you have any questions, of course, you can leave them in the comments below. And all the materials that I mentioned is available in the description. So see you soon.